Welcome, viewers. This is our Motion in the Media project. I'm Joel.
And I'm Brandon. Okay, I'm Jacob.
And that's Shaq. We're going to be picking apart the classic 1996 video game, NBA Showtime. And apparently, it's on NBC. Before we start, we'd like to make a few things clear. We took a still image from the game. We knew that the rim was 10 feet tall. And we put it on paint, and we found that there are 300 pixels between the rim and the floor. So therefore, 30 pixels equals 1 foot, and we'll be using that scale for all of our measurements the entire time. The aspect of the game that we are going to analyze is projectile motion. It's going to be a full court pass from Kobe, who will be in the paint on the right side of the floor, to Shaq, who will be on the paint on the other side of the floor. We'll let you watch the video and then we'll pick it apart. Alright, first in fast motion and then in slow-mo.
Sorry about the poor quality of those last two videos. I guess that's what you get when you combine the 1990 video games with janky software.
Alright, so that pass was in the air for a total elapsed time of 0.8 seconds. But we're going to focus on the maximum height of the ball, and that was at the halfway point, so all we care about is 0.4 seconds. To find the height, we're going to use the distance free fall equation, which is 1/2 times 9.81 meters per second
Squared.
times 0.4 seconds squared. And when we punched that into the calculator, it came out as 0.78 meters. So at the height of its path, it was 0.78 meters higher than when it started. Alright, so to find the horizontal distance the ball traveled, we took the length of a regulation NBA court from foul line to foul line would be 56 feet. And we saw that they threw and received the pass about 3 feet into the paint, so we added 6 to get 62 feet is how far it traveled. Converted that to meters, it was about 19 meters. So that would be the horizontal distance. But since we're only working from halfway, as we did before, we're going to chop that in half. 9.5 meters is the half horizontal distance. So we used the maximum vertical distance as one leg of a right triangle, and half of the horizontal distance as the other leg of the right triangle, so that we could find out the angle of the pass thrown and received. Using the inverse tangent formula, that came out to be right at around 4.7 degrees. Alright, so in summary, we found that the maximum vertical distance that the ball traveled from its starting point was 0.78 meters. The distance from the halfway point to either end was 9.5 meters, and therefore the angle was 4.7 degrees. Now we're going to take a look at the game and see how our math matches up with the game itself.
So here's where the pixel conversions come in. By using paint, we figured out that this ball is actually 1.8 meters higher than when it started. Mathematically, it should be only 0.78 meters higher, so it's way off. A pass of this length and time in real life would have to be on an even flatter plane than shown in this game. Then, by using the pixel scale, we figured out that this ball travels the equivalent of 15 meters horizontally compared to the 19 meters it should have traveled mathematically. You may recall the half distance last time was 9.5 meters, and on this game it is 7.6. Close, but no cigar. Recall that this pass would be thrown at a 4.7 degree angle in real life. Using our distances of 1.8 and 7.6, we're going to recreate another right triangle to find the angle of the pass on this game. Using the inverse tangent formula, once again, we get an angle of 13 degrees. That's way more than 4.7 degree real life angle. So we know that the maximum vertical distance, horizontal distance, and launch angle are all off on a considerable amount. It shouldn't surprise any of you to hear that NBA Showtime is nowhere near being scientifically correct. This game has officially been busted.
And if all of that wasn't convincing enough, Shaq just made a 3. This game is garbage.